So we're going to be looking at the Intermediate Maths Challenge, the one that was done just this week. I'm going to speedrun it, see how fast I can do it, see if I've seen, like, I've tried to avoid as much as possible, but I have seen, like, one or two questions. But yeah, I can try and see how fast I can do it, how accurately I can do it. I imagine I'm going to get about 20 of them right as fast as I can. So let's start the clock. Okay. So, which of these numbers is neither a multiple of 3 nor a multiple of 4? Okay, that's a multiple of 4. That's a multiple of 3. That's a multiple of 4. That's a multiple of 3, so it's 34. Area of this triangle. Okay, it's a classic Pythagorean 3, 4, 5 triangle. So the area is just the 3 times the 4 divided by 2. The 5 is there to trick you, so it is 6. What's the value of this thing here? Oh, God. Okay, so this bit, in fact, I'm going to make this pen much smaller. So this is minus 1, and then I've got 3 minus 4, which is minus 1, minus minus 1, which is 0. 2 minus 0 is 2. 1 minus 2 is minus 1. Ugh. Okay, each of which contains 2 midpoints inside of the square. What fraction of the area of the square is shaded? Okay, if I do this, and then I can do that. Okay, so it's one piece out of, in total, that is 16 pieces. 1/16. We know that is 10. It is also true that that's cubed is 10 to the n, so that's 1 plus 8 plus 81 plus... Okay, well, wait. We also know that it is also true... Wait, what? That's 81, right? 27. No, that's 27. Oh, and that's 64, so it must be squared. Yeah, okay, cool. You need 8 straight lines as shown. How many straight lines do you need to draw an n by n square grid? So let's say if I just add, if I make the grid a bit bigger, how many lines have I actually added? I think I've only added these 2 lines. That's it, so it just goes up by 2 every time. So I think it has to be 2n plus 2. Nope. Okay, I've lost all my things. It was a minus 1. It was a 6. It was a... This is not fast, is it? A 34. It was a 1/16. It was a 2. I think this is going to be 2n plus 2. Yeah, because we start with this, which is 4. Yeah, it's 2n plus 2. What is 0? Oh my god, of 60 million. Okay, so 60 million, 60, and then 1, 2, 3, 4, 5, 6. 0.0... What the... Okay, so 1% is this. 60,000. No, 600,000. Oh my god. 0.1% is 60,000. 0.01% is 6,000. 0.005% is 3,000. So we add those together and we get 9,000. That is horrible. I feel like I could have made a silly mistake with that, but we're fine. Okay. The cube root of the cube root of x is 3. Okay, so if I square it once, I get the cube root of x equals to 9. I can square it again. X equals to 81. Remember I've done the numbers. One for the number. What's the median of her 5 numbers? 0, 2, 2, 3. Okay. If it's bigger than 3, it's the median's still 2. If it's less than 0, the median's still 2. So it's always 2. Always 2. Okay. I'm not sure if the camera's still, but I'm over here. Okay, each of the digits 89 inclusive is used to fill in the cells with the cross number. What are the sum of the 2 digits which are not used? So 1 across is a power of 5, so this has to be a 5 or a 0. 5 or a 0. 2 across is a power of 4. 1 down is a power of 6. So the power of 6s, I wonder if 6 is a number. I don't think it... Oh no, this won't be a 0. Okay. So we've got... It basically has to be 36, right? That has to be 36. Because it's a power of 6, and 6 cubed is too big. A power of 4 that ends in a 4, that means this number has to be... Well, these two have to be a multiple of 4. Oh no, it's a power of 4. Oh my word. Okay. And that's a power of 5. Wait, powers of 5 always end in a 5. So that's a 5. Powers of 5 always end in a 5. Powers of 4 that are 4-digit. Wow, I really don't know what the clever thing is here. Am I just going to have to do it? I mean, 5 cubed is 125. Times 5 is 675. Okay. Times 5. 5, 2, 5, 35, 7, 3, 5, 6, 33. 3, 3, 7, 5. What? Wait, what? But 3, 3, 7, 5. Oh, wait, what? But that word doesn't work. Okay, I must have done. Oh, this is wrong. Okay. 125 times 5. 5, 2. Nope, 5, 2. 5 times 5 is 10. Add 2 is 2. 725. Okay, so now we're doing 725 times 5. This is. I wonder what the clever thing for this is. 5 times 2 is 10. Add 2 is 12. 5 times 1 is 30. 3625. No, wait, that doesn't work. That doesn't work either because these can't be a 6. What? Okay, powers of 6s. 0, 6, 36, and then something much bigger. Okay, so it can't be 3625. What am I doing? Okay, let's rub this out. Let's try again. Okay, 3 blank blank 5. So we've got 5, we've got 25. If I times that by 5, I get 125. When I times that by 5, so 125 times 5. So that's 25. 5 times 2 is 10, add 2 is 12. 5 times 1 is 5. Add 1 is, it is 625. What is going on? Why can't I do maths? 5 times 5 is 25. 5 times 2 is 10, add 2 is 12. 5 times 6 is 30. Oh my god, it's 2125. Can't do maths. Okay, so now I have a 4, I have a 7, an 8, and a 9, and a 0 to get to powers of 4 ending in a 6. Okay, let's rub this out. Powers of 4 ending in a 6. So we've got 4, we've got 16, we've got 64, we've got 256 times 4. Oh, it's going to be this times 16, that times 16, because when you times it by 4, it's going to end in a 4. So when you times by 16, it's going to end back in a 6. So 6 times 6 is 36. 6 times 3 is 30, 33. 6 times 2 is 12, add 2 is 15. 0, 6, 5, 2, 6, 9, 1. Is that 5? Yeah. 1, 1, 4, 1, 9, 6. 4, 1, 9. No! That's wrong. That's wrong, because you can't use 1 twice. What if... Oh my god, there's no carry here. 3 plus 6 is just 9, so that's a 0. But that's still a 1. 4, 0, 9, 6. 7 and 8, 15. I have no idea. What was the clever thing here? Oh my god, that was absolutely horrendous. Okay, we move on. Children large jam to give 1/6 of a jar to Jan. Children gave 1/13 of the remaining jam to Jazz. Jill was left with 1 Jazz. Okay, so we start with jam. And then she gave 1/6. So we have 5/6 of J. That's what's left. And then 1/13, and then minus 1/13 of J. And that equals to 1,000 grams. Okay, 5, 6 minus 1/13. 6 times 13 is 78. Yeah, so we've got 65 over 78J minus 6 over 78J equals 1,000. So we've got 59 over 78J equals 1,000. No. 59's a horrible number, isn't it? Is that prime? I'm doing something stupid. Okay, so we've got this. This is the original, but that, what on earth am I going to do here? It's 59. This just seems horrible. Okay. I'm doing something stupid. How am I doing stupid? 5. So she gave 1/6, so she's left with 5/6. And then she gives 1/13 of the remaining to Jazz, so she loses a 13th. No, okay, I've set this up wrong. Okay. She has 5/6, and then she loses a 13th of the 5/6, and that equals 1,000. Yeah, because it's a 13th of what's remaining. So I still feel like this is wrong, but let's go with it. So 5/16. Oh, and we can actually factorize out the 5/6. So we've got 5/6 lots of j minus a 13th j equals 1,000. This is 12/13. So we've got 5/6 of 12/13 j equals 1,000. Okay, this feels better because these cancel. So we've got 10/13 j equals 1,000. So we've got, okay, there we go. We get 130 or something, or 1.3. Okay, because we times it by 13 divided by 10. Ugh, that felt horrible as well. Not in a good rhythm at the moment. Okay. What's the angle of size WTS? So that's this angle. Okay, so this is 60. This is 90. This is 60. In a regular pentagon, we've got 180 lots of 5 minus 2 over 5, which is 540 divided by 5, which I'm pretty sure is 108. Yeah, that's 108. Wait. Am I doing this stupid again? So this is also, no, I want, oh yeah, that's fine. Okay. This is also 108. This is also 108. And then this angle here is 360 minus 150 minus 258, which is 102. So this is a, let's put this in a different color. That's 102. I want that. What's this? How do I find that guy? Okay, what's it? Am I regular pentagon? Okay, this is cool. This length, because it's part of a square, is the same as this length. It means this length is the same as this length. So this is actually an isosceles triangle. WST is an isosceles triangle. That is cooler than I thought it was. So we've got, this is 102. And then these two have to add to 78, so each one's 39. Okay, that's actually cooler than I thought it was. The mean of P and Q is 13. Okay, we're going to get some simultaneous equations. So we've got P plus Q over 2 equals 13. We've got Q plus R over 2 equals 16. We've got R plus P over 2 equals 7. And we want to know what's P plus Q plus R over 3. That's what I want to know. Okay, this is one of those classic math challenge simultaneous equations questions. So I times everything by 2. P plus Q equals 26. Q plus R equals to 32. R plus P equals 14. The most classic math challenge question ever. Because then we add these together, we get 2 lots of P plus Q plus R equals to this added together, which is 40, 72. Divide that by 2, P plus Q plus R equals 36. So the mean of P plus Q plus R is that divided by 3, which is 12. Great question. Love that. Okay, let's rub out some working. Next, an irregular octagon has side length of 2, and I shape. Okay, no, gotta draw it. I shade the rectangle. Okay, one sec. P, Q, R, S, T, U, V, W. When I shade the rectangle, P, Q, T, U, that's this guy. Four small, and R, S, V, W. Four small triangles inside the octagon remain unshaded. What's the total area? Okay, so this is 2. 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 Okay, Pythagoras. These lengths are the same. X, 2. 2x squared equals to 2 squared. Base a squared plus b squared equals c squared. X squared equals to 2. X equals root 2. So that's root 2. That's root 2. Total area of the 4 triangles. Well, this triangle here is just root 2 times root 2 divided by 2, which is just 1. This is 1. This is 1. This is 1. Total area is 4. Definitely a better way to do that. I bet, like like this, and this, they just add to make this, and that has an area of 4. So made that overcomplicated. Okay, how many of the following polygons could exist? Oh no, I wanted to rub that out. A triangle with all 3 sides the same length, but 3 different interior angles. No, because if all the things are the same length, the angles have to all be the same. Equilateral. Quadrilateral, all 4 sides the same length, but 4 different interior angles. Also no, because it has to be a rhombus or a square. A pentagon with all 5 sides the same length, but 5 different interior angles. 1, 2, 3, 4. No, wait. Wait, what? 1, 2, 3, 4. Have I made assumptions here? With the quadrilateral, I draw a line, and then the other line can go here. And then let's say the other line, no, for it to connect back here, it has to go there and there. The pentagon, that could work. And then if I tilt it a bit to the side, like that, could that work? Whoa, I got absolutely no idea. Okay, I'm going to circle 15. My assumption is it's either this or this. Don't know which one. Going to come back to that. Okay, that was weird. The sum of the lengths of the 3 sides of a right angle triangle is 16. The sum of the squares of the lengths of the 3 sides is 98. Wait, what? A plus B plus C equals 16. A squared plus B squared equals C squared. And the sum of the squares of the lengths of the 3 sides. A squared plus B squared plus C squared equals to 98. But we know that this is true, so that's this. So 2C squared equals 98. C squared equals 49. C equals to 7. That's 7. We're looking for AB over 2. We've got A plus B has to equal to 9 because C is 7, and we've also got that A squared plus B squared equals to C squared, which was 49. Okay, we want AB over 2. Oh, okay. Yeah, I don't think we need to find things out. I think this gives us A squared plus B squared plus 2AB. This is one of those nice maths challenge questions where you don't actually need to find out A and B, you just need to find out AB over 2, because we're finding the area. So here, if I know this, that means that 9 squared, because this is this, 9 squared equals to this, which is 49, plus 2AB. I like these ones. 81 minus 49, that's 32. So 32 equals 2AB. AB equals to 16, so the area is 8. That's a really cool question. You don't need to solve this, you just use this thing. Math Challenge loves that. Okay. 3 by 2 rectangle is split into 4 congruent right angle triangles, as shown in the left-hand diagram. These 4 triangles are rearranged for a rhombus. Okay. So that's 1.5, that's 1.5, that's 1.5, that's 1.5. What's the ratio? Okay, what am I doing? The ratio of the perimeter of the rectangle to the perimeter of the rhombus. Okay, so the rectangle is 6, 10. Okay, now the rhombus. Now, this is 1.5, this is 1.5, this is 2, this is 2. I mean, just Pythagoras, right? And then probably a clever way of doing it, but I'm just going to do Pythagoras. Okay. 3 over 2 squared plus 2 squared equals to c squared, where this is c. So 9 over 4 plus 4 equals to c squared. 4 is 16 over 4, so we've got 25 over 4 equals c squared, so c equals 5 over 2. 5 over 2. The perimeter, so the perimeter of the rhombus is 5 over 2 times 4, which is 10. Wait, what? They're the same. That's cool. That is unexpected. That is unexpected. 1 to 1. Oh, that's neat. That is very unexpected. I do not think that generalizes. Okay, I'm not really doing it as fast as I can, but that's fine. How many squares are exactly 4 greater than a prime? So, honestly, have seen this one before because I got asked about it, but I did get it. Or as in, I got it because this felt classically difference of 2 squares. So 4 greater than a prime. So we've got a prime plus 4 equals to n squared. And because I love difference of 2 squares, I immediately was like, oh, ho, 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 this is a cool question. Okay, so a prime is a number add 2 times a number minus 2. But we know primes aren't composite. One of their factors has to be 1. So either this is 1 or this is 1. If n plus 2 equals 1, that means n is minus 1, which can't work. Because we're dealing with that we're not dealing with negatives, we're just dealing with positives. So n minus 2 has to equal to 1, and there's only one outcome. N is 3. So the answer is 1, but what's cool is we know which one that is. It's 5 times 1, which is 5. 5 is the only prime 4 greater. 5 is the... Oh, wait. Wait, did I do that wrong? How many squares exactly 4 greater than a prime? N is 3. The prime. Oh yeah, okay. Whew. The prime. Okay. N is 3, the square is 9, the prime is 5. That's pretty cool. There's only one in the world, even though there's infinite primes. That's pretty cool. What is the positive difference between the numerator and the denominator when the expression shown is written as a single fraction in its simplest form? Oh god, okay. Let's do the bottom. N minus 1 times n plus 3 over n plus 3 minus n plus 2. Okay, that's the denominator. I've just common denominated it. I've times this by n plus 3, and I've divided it by n plus 3, and then I've just subtracted them. So that's n squared plus 4n plus 3 minus n minus 2 over n plus 3. This is still the denominator. So that's n squared plus 3n plus 1 over n plus 3. Okay, and we're doing n divided by that. N divided by that. So we flip it and times it. So that's n squared plus 3n plus 1 over n squared plus 3n. And it's asking what is the difference between the numerator and the denominator. The difference is just this one. That's pretty neat, I think. That's just an algebra question. Okay, not super interesting, but cool. I roll 2 standard 600 fair dice. At least one of the scores obtained with the dice is 3. What is the probability that both of the scores on the dice are 3? What? Okay, so there's only 3 options. So, okay. What about... So it's the probability of a 6... Oh no, of a 3 given that I have a 3. What? Why am I overcomplicating this like crazy? The probability of A given B is the probability of A and B divided by the probability of B. So the probability of a 3 given a 3 is the probability of 3, which is 1 over 36, divided by the probability of B. The probability of just getting a 3 is a 6th. So it's a 6th. I feel like that's really obvious, and yet I'm absolutely baffed. Is that not really obvious? It's just what's the probability of getting a 3? What? Okay, I'm not sure about 20, because I'm not sure about 20. 21. A semicircle of radius 3 units is drawn on one edge of a right angle triangle. A semicircle of radius 4 is drawn on the other edge. Okay, we're going to be zooming in. Semicircle of radius 3 units. That's this one. So if the whole thing's 3, this length is 6. And this one is 8, which means the hypotenuse, because of my Pythagoras, is 10. What is the shaded area in square units? Okay. What? Okay, wait. This length is 4. This length is also 4. Yeah? That length is also 4. Yeah, and similarly, we've got a 3 and a 3. But I don't quite see how that helps us. I don't know the formula for... How do I find this angle? Cosine rule? Oh, wait. I can do trig, but I don't know my exact values very well. 6 and 8, and that's a theta. So tan theta equals 3/4. I don't know what arctan of 3/4 is, but okay. I'm overcomplicating this a lot. But if tan theta is 3/4, then sine of alpha is I know this as well. Sine of alpha is the opposite of the hypotenuse, is 3/5. So I can actually use this because I can do half AB sine alpha. Okay, this angle. No. I'm overcomplicating it. This is... I've gone A-level in a world where I need to be going GCSE. Okay. Stare at it. How do I... The whole thing is half AB sine C. No, the whole thing's pi r squared. Divided by 2, it's pi r squared over 2. Let's just write some things down. Okay. This big one, if this is 4, then it's 8 pi. Because it's pi r squared over 2. The small one, the smaller one, this is 3, is 4.5 pi, so 9 over 2 pi. But then, what? Like, I feel like I could do this with trig, but I don't want to. Like, these are all the same. Let's double dash them. And these angles add to 180, and so these shapes, there's something here that I'm not getting, because this guy and this guy are both those segments, are both the segments, and then this guy and this guy are also segments. So what I have is I've got a 4, 4 something thing, and I've got this segment, that's segment 1, and then I've also got the other 4, 4, 1, the other 4, 4, 1, and I've got this segment. Similarly, but those areas can't be the same. That's fine. And then similarly, I've got the exact same thing with 3s. I've got the 2 options for 3s, the acute one and the obtuse one, and I've got this. What am I trying to do? What's the shaded area? I'm missing some very, I imagine, some very silly information. And I also know that I haven't used the 10 at all, aside from this, but that's much too complicated. I just know that A plus B equals to 10. Okay, the area of the triangle is 6 times 8 divided by 2, so it's 24. And then, I mean, like, if we're really going to overcomplicate it, like, I could cosine rule, because I know cos of theta, but I don't. I know cos of this theta. What am I doing? Am I just meant... I'll come back to it. I'll absolutely come back to it. Okay, the numbers x, y satisfy these equations. Okay, this one I've also seen before because my students asked me about it, but I know how to do it straight away because it's one of my faves. This is such a another math challenge classic. So we're doing a mixture of the simultaneous equations adding thing that we did earlier. So if I add them up, I get 1,000 x plus 1,000 y equals to 5,000. Oh, 5,000. So x plus y equals to 5. Nice. And if I subtract them, I get 954 x minus 954 y equals to 954. So x minus y equals 1. And then we're looking for x squared minus y squared, which of course, my difference of two squares, x minus y times x plus y, it is 5 times 1, which is 5. Love that energy. That's great. That's a great question. Is it possible to choose in 2 different ways 6 different integers from 1 to 9 inclusive such that their product is a square? Oh, it is possible to choose. Okay, we've got AB is a square. Wait, it's positive 6 different integers. Oh, the product of 6 numbers is a square. What? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So for their product to be a square, you can't have any primes. You can't have the primes because you need 2 of them. Oh no, wait, you can. Sorry, you could have 3 because the 3 could match with the 9. So for example, 3 times 6 times 9. This is almost a square because we've got 3 to the power 4. We need a 2 in there. And then we need a 4 and an 8. Like that. Now this is a square. No, it's not. No, it's not. This is a square. Because, yeah, this is a square. Because I've basically got 3 to the power of 4 times 2 to the power of 3, 4, 5, 6. Yeah, which is a square. Okay, that's one. And the other option is that I get rid of 4, and I replace it with 1. Oh no, wait, sorry. I need 6 different integers. So this is the first set. That's set number 1. 3 times 6 times 9 times 4 times 8 times 1. This works. And so does 3 times 6 times 9 times 4 times 2 times 1. That's also a square. Because, yeah, the 2 from here matches with the 2 from here. So we've got basically 3 times 3 times 3 times 3 times 2 times 2 times 2 times 2. Yeah, 2 squares. Here we go. What's P plus Q? Okay, so this is 3 to the power of 2 times 2 to the power of Q, 3 squared. So that's what P squared is. That's P squared. So P equals 9 times 8, which is 72. In this case, I've got 3 to the power of 4 times 2 to the power of 4, which is 3 squared times 2 squared, which is 3 to the power of 4. No, it's 9 times 4, which is 36. The sum, so P plus Q, equals to 108. That is a class question that I absolutely did not understand straight away. That is really cool. That's a really cool question. Okay, how many go? I've got a few questions left. The rectangle has side lengths A and B, where A is less than B. The rectangle P2UV has side lengths C, D. Okay, we need Q. I'm getting my ruler out. This is definitely cheating, but whatevs. What a nice diagram. Oh wait, they've drawn it so they're not on a straight line. That's so annoying. But it's fine. Now this can leave. What conditions must be guaranteed so that that is a straight line? This feels like maybe it's a vector question. Ugh. What do we know about it being on a straight line? I feel like there's a vector thing. Because if like this is parallel, if like Vx is parallel to xq, if that's true, then it's a straight line, but it's not. That's not true. Maybe it's Vx is parallel to Vq. how am I going to go about proving that? Okay, so Vx is the vector d. Let's imagine these are vectors. D's that way. And then plus some amount of VQ. That's an assumption. I've just assumed that like crazy. Just assumed. This is assuming that Vx is parallel. I feel like there's a straight line graphs way of doing this. That's my instinct. What am I actually being asked? Okay, right. This is the side length. The sides are S, T cross X. These can just guarantees that they lie on a straight line. Does it always lie on a straight line? No, because if they crossed here, for example, then they obviously wouldn't lie on a straight line. Okay, so there is, okay. So something about this, and this, and this, and those two. But I don't know why. But I'm imagining it's something like B over C plus A over D. I know D over A equals to 1. No idea why. Is that one of my options? Nope. But A over D plus C over B. That's an option. Absolutely no idea why. Does D need to equal B? Nope. Absolutely no clue. Absolutely no idea. No idea. No idea. Okay. Chord PQ of the larger circle. I'm still thinking about that pentagon question from earlier as well. Two untangents which touch southern north touch the larger circle. Okay. This is also going to be a big redraw job. Okay. Let's just rub everything out. Okay, so there's also something about two circles inside a bigger circle, about their radiuses. I don't remember what it is. I don't exactly remember what it is. But if that's A, and that's B, there's something where it does, like the area is the same. It's something like the area is the same no matter what the radius of these circles are. There's something about that. I don't remember what it is though, and I'm not going to try and prove it right now. Okay, let's draw the thing. Got this. Got that. And got that. And now let's do some labeling. Okay. So, X, Y. 3, 3. There's absolutely there's some similar triangle stuff here as well. Because these angles, I think, are the same. Or like the ratio stuff the same. There was a puzzle like this on Mind Your Decisions at some point. I don't remember what it was, but something like this. I remember doing it. Okay. also just put the center of this big circle there. The trick of this is going to be finding the radius of the big circle. And then it's something like the areas of the inside circles don't, like it's always half or something. That's the instinct. Okay, is this a similar triangle? So this and this is the same as this. And I feel like in a kite, these two add to 180 and these two are the same. So let's say this was A and A, B, B. This down here is 180 minus A. So this one is 90 minus A over 2. This one is 90 minus A over 2. That's 90. So that's B over... Oh no, wait. Wait. It's not. It's not. It's definitely not. Because this angle up here is 2A. So this is 90 minus A. And this is 90 minus A. And so this over here... Oh, and B is 90 minus A. So this is B. Okay, I was right. There's similar triangles here. I just had to prove it to myself. B is 90 minus A. So this is B. And this is B. Which means this is A and this is A. So we've got similar triangles. Okay. So this length is 2x. This length is 3. And we also have similar kind of vibe. But this is 3 and this is 2y. Okay? How that helps us? Don't know. 2x over 3 equals to 3 over 2y. So 4xy equals to 9. So xy equals to 9 over 4. Okay. What else we got? Area of the sector? Like, I can find the area of each of those triangles. That doesn't matter. Okay, any Pythagoras shenanigans going on? Like, why would it matter if those two? I'll just get the same relationship between them. Like, if this is 3 squared plus 2x squared, that's going to be 9 plus 4x squared, the square root of 9 plus 4x squared. Nah, mate. Nah, that's not it. Or there's some facts here that I don't know. Okay, we've got this. Is that enough? Is that the answer? Okay, the area of this circle, the area of the big circle, is pi times y squared. And the area of the little circle is pi times x squared. Now, the area of the whole circle, well, we've got this length, this length, this length. This length is 3. Is that a similar triangle? Mate, there's a formula for finding the radius of a circle from 2 chords. Like, there's a Mind Your Decisions video which is clickbaity that just looks like this, and it's like you can find the area from this, but how? Is it like this? Oh, mate, do I even have a video on my channel about this? Because these are the same. How can I use that here? Okay. This is the radius. This length is the radius minus x. minus 2x. That's the radius minus 2x. So for this right angle triangle, for the star one, I've got r minus 2x, and I've got 3. Okay, so we've got r minus 2x squared plus r squared equals to 3. Nope. We've got r minus 2x. I'm actually running out of time. 2r squared. So we've got r squared minus 4xr plus 4x squared plus 9 equals r squared. So if I get rid of my r squareds, I'm left with 4x squared plus 9 equals to 4xr. Interestingly, this length here, this length was 4x squared plus 9. This is the square root of that. And that was that length. So the square root of that. Now, why would I? So r equals 4x squared plus 9 over 4x. I mean, not super helpful. Unless I do something similar with y. Is there, okay, this radius here, on this radius, but we don't know how much of y it goes along. Mate, there's something about the fact that if you just, the area is the same. So the radius is x plus 9 over 4x. Nah, that's horrible. What other expression can I make for the radius? What other radiuses are there? There's this one. Wait a minute. This is r. This is r. And I've got this triangle here. That triangle here. That's r. That's r. This length is this length, which is the square root of 9 plus 4y squared. I haven't really used the 3 much. Like this length up here, because of this, is the square root of 4xr. But that don't help me. I need another, I feel like this triangle, but what's this triangle even giving me? I'm running out of time. I mean, this is an isosceles, that's R, that's R, that's B, hold on, that's A minus B, that's 90, that's B and B, so that's 180 minus 2B, which means this one is 2B, and then so I've got, okay, maybe I'm getting somewhere. I feel I'm going to get something silly. That's 2B, and that's A minus B. So that means that I've got 2b plus a minus b equals to 90. Did I? Obviously, I've just got a plus b equals 90. That's not helpful. Are there more similar triangles? Is this one similar to this one? Why would that matter? Oh, I've drawn too many things. It's got too ugly. There's something in this. A over, so we've got these two similar triangles. And we've got that C over B equals A over D. DC equals AB. Have I used that here? One sec. DC equals AB. Hold on. Oh, wait. Oh, I've just got 9 equals 4xy again. I knew that anyway. Ah, that is definitely part of it. And the other part is something to do with circle with 2 circles tangent inside it. Hold on. Am I being an absolute doofus? 2x plus 2y equals to 2 radiuses. Oh my gosh, running out of time, but I think I'm getting somewhere. Oh my gosh, x plus y is the radius. X plus y is the radius. This is it. That's what I'm missing the whole time. Oh my word. Okay, so we've got 4xr equals to 4x squared plus 9, and we've got x plus y as the radius. So we've got 4x lots of x plus y equals 4x squared plus 9. We've got simultaneous equations because we've got 9 over 4 equals xy. Don't think this is actually going to help at all, but it's fine. So we've got 4x squared plus 4xy equals 4x squared plus... Wait, just end up with 9 equals 4xy again. X plus y is the radius. So we've got pi r squared minus pi y squared minus pi x squared. So we've got pi r squared minus pi... And we've got x plus y is r, and x plus y squared equals x squared plus y squared plus x 2xy. So we've got x plus y squared equals this, which is there's some Pythagoras going on here. That plus 2 lots of this, 9 over 2. Pi of x plus y squared minus pi of y squared minus pi of x squared. So pi, and here I've got x plus y squared minus x squared minus y squared. So pi of... Oh, I've run out of time. Oh my god, it's just pi of 2xy. But we know xy is 9 over 4, so... the area of the whole thing is 9 over 4. Pi. Oh my god, and it's a half. No, wait, that's wrong. No, wait. No, wait. I've rushed that like crazy at the end. 2xy, then the xy, those cancel out. We're left with just... So the shaded area is just pi times... Okay, I've run out of time, but I think I'd got it. Pi times... Yeah, which is 9/2. Have I got it? Okay, let's just slow down. Okay, let's go back to this. Pi... Okay, I've run out of time. So we'll mark, but pi lots of x squared plus y squared plus 2xy minus x squared minus y squared. That's the shaded area. These cancel. We've just got 2xy pi. That's it. But we know xy is 9. Oh my god. We know xy is 9 pi over 4. No, it's... What's xy? It's 9 over 4. Over 4. So the area is just 2 times 9 over 4 times pi, which is 9/2 pi. I'm such a legend. Okay, that was like last second stuff. Okay, it unfortunately didn't do 24, or I didn't do 15 at all. 15 was scary. But yeah, 15 and 24. Oh my word. Okay, Crash 25. Did a lot of faffing about. Actually clutched it with like on the second. We will look again, but on the second. Okay, let's mark our work. Mate, that was some strees. Let's pause our timer. Pause. I think I can actually... Okay, let's just leave it. Actually, I think I can insert... well, I'll mark, I guess. Let's get a nice green pen. Let's make it bigger. Okay, so that was 34. I guess we can zoom in a bit. Pythagoras' theorem, yeah, that's A, that was B, that was D, that was B, that was E, that was B, that was E, yep. 9 was B, yep. Okay, going on to the next set, which is these. 10 was D, good. 11 was B, 12 was E, yep. 13 was A, yep. 14 was C, yep. And 15 was A. Ho, ho, ho. I actually knew, okay. I know I said B there, but A was the one I thought could be. A was the one I thought could be. A was the one I thought could be. Okay, so I'm half giving myself that. So that's 15. See you later. Absolutely flying so far. Well, we got over here the next set. Okay, 16A, yup. 17C, yep. 18B, yep. 19E, yep. 20B. No! I thought this was... Okay, I thought that was wrong. 36 differently equal poly outcomes for 2 dice. The number of those which involve only 1, 2, 3, 4, 5, or 6. Wait, what? Oh. Oh, I think I wrote my equation wrong when I was doing with conditionals. Probability of A and B is what I was looking for. Okay. Sad. 21. Oh, I didn't get this one either. Oh, I didn't get this one. Oh my god, this is like a semicircle Pythagoras thing. Oh my god, I actually have seen this before. Oh, I didn't get this one either. As the semicircles intersect on the hypotenuse, the shaded area is the sum of the areas of the 2 semicircles minus the area of the right angle triangle. What? That's it. Why? What? Oh Oh my word. It's just... Oh my word. Okay. Okay. If I look at this again, now this one took me... Okay, let's look at this. If I split this into sections, the areas here, I've got the right angle triangle, I've got the triangle, plus the semicircle, plus the semicircle. No, wait. I've got the whole thing over here, then I've got the whole thing over here. So I've got that thing, I've got that thing, and I've double counted that. So I just need to, it's the whole thing plus the whole thing, and then I take away this thing, and it gets rid of those. Oh my word. Okay. Did not get that. That's sad. And then, finally, the last questions over here. Oh my god, I got question 25 right. Let's go. Okay, bit of a mess. 22E. Yep. Let's go back to my green. 22E. Yep. 23 is 108. Yep. That was really fun. 24 is C. Oh! Love a fluke. And this is 9 pi over 2. You know what? I'll take that. Overall, 23 out of 25. 23 out of 25. Messing up this one, which feels sad. I feel like that's just like an inclusion-exclusion problem that I didn't notice. And the probability one, which I absolutely flopped on. Absolutely blew. Like, no idea. And let's be honest, 24 I fluked. But I'll tell you that. Okay. Thanks for watching. Hope you did it yourself. I don't know what possible there is to learn from here, but I had fun, so that's good. And I'll see you in the next one. You're going to see some recording screen now. Bye.